Okay, this is rational zero test, which is probably new to many of you. And what it is, it says if you have a function f of x and it's a polynomial, and so mathematicians write polynomials this way. Well, that's a lie. We write them reverse of this. This is good enough. So we have ourselves a polynomial, and it has integer coefficients. So all those a's are integers. Then every rational zero, that means any root, anywhere this thing crosses the axis that's a rational number, must have the form x is the root, p over q, where p is a factor of a sub 0 and q is a factor of a sub n. Okay, what it means for you is I would not on an exam ask you to do a problem where this coefficient is anything other than 1. Okay, this guy, well, let me put it this way, either an is going to be 1 or a naught is going to be 1. I'm not going to ask you to split up both of them. It becomes really obnoxious. It's obnoxious in the same way factoring quadratics is obnoxious. Okay, but it's actually worse. Okay, but let's not get into that right now. Let's talk about how cool the theorem is, because it's super cool. It's just can become tedious. Okay, so it does not say the roots are rational. Note, does not promise rational roots. It does not even promise real roots. Doesn't promise real roots at all. Doesn't promise rational roots at all. You may say, wait a minute, you just said the rational roots have this form. Yes, only the rational roots have this form. If it's an irrational root, it doesn't have to follow the rules. Irrational and complex are exempt from the rule. That's kind of rude, but it's kind of true. Well, it is true. Okay, let me give you an example. If f is x cubed plus 8, what happens? Then it has, if it has rational roots, first of all, does it? I purposely picked something, right? So let's see. It must be one of these. And so I'm going to ask you to be able to generate this list of possible roots. In this case, we're lucky because we only have this guy can break up into 1, 2, 4, and 8. Those are the only factors. And this guy, factors are just 1. Alright, so we have to take a factor of 8, divide by a factor of 1. That's pretty easy. So plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. Those are all the possibilities. I'm sorry that I started writing in red. There we go. Okay, so we go back and say, well, we think f of, let's try 2. That's not going to work. 8 plus 8 is 16, but aha, we're pretty close. F of negative 2 is 0. Yes, we have said that in this list there was a negative 2. So what the theorem is saying is if one of the roots or more, if at least one or more of the roots is going to be a rational number, that means an integer over an integer, then it has to be in this list, and that worked. Okay, so let me ask about this question. What if the function is x squared minus 7? Then what is it going to do? It's going to generate, okay, what are the factors of 7? Don't worry about the negative sign. I'm just going to put in all the positives and negatives anyway. Factors of 1. So the factors of 7 is just 1 and 7, and we only divide by 1. So this is the whole list of what we're allowed to use, right? So we're allowed to use plus and minus, yeah, right now it's black, okay. Plus and minus 1 and plus and minus 7 are the only things we're allowed to use. However, none of those work. You can try plugging them all in. None of them give you zeros. The roots are, in fact, we know the roots are plus and minus square root of 7. However, this guy is irrational. So the rule does not apply to him. Does not have to follow the rule. Okay, got it? Okay, hope that drives the theorem home. Let's do an example. So here's what I can do. I can give you this type of question. List all possible. Now this is the wording of the question. List all possible roots or rational zeros for f equals x cubed plus x plus 1. Test them. Test them means plug them in and see if they work. Okay? So what we would do is we would say, okay, factors, this is easy, is just 1. And factors of this guy, and I just mean the coefficient in front of him, is just 1. So the answer is that the set is just plus or minus 1, and we want to try both because the question said to. So f of 1 is 1 plus 1 plus 1 equals 3, fail. And f of negative 1 equals negative 1 minus 1 plus 1 equals negative 1, fail. This thing does have a root, but it has no rational zeros for our function x cubed plus x plus 1. So this is one thing the theorem can do for you. It can eliminate possibilities, and this you can tell will be really easy for a computer to do. It could just run through all the cases and say, is there a rational zero in this function at all? And the answer is no. This is a cubic. It has to look like that, okay? Or some variant of that, right? So it has to have a root. It may even have two roots. I don't know. It could have a double root and a single root. It could have a single root. It could have whatever, okay? All the possibilities we normally have for this situation. But none of them can be rational, so it can't sit on an integer or any other rational number. Okay, next one. This is supposed to be for you to try, so after I set the problem up, I want you to pause and try. Okay, actually find rational zeros, meaning all rational zeros. Okay, I think it's all actually going to be rational. Let me peek ahead. Yeah, all the roots are rational. So find the rational zeros of this guy. Now let me just, before you pause, let me just say something. Isn't it obvious that if I told you in advance that there's 3 integers, I'm telling you that, there's 3 integers, it's going to look like this. X minus, some number, x minus some other number, x minus some other number. Okay, if you multiply that all out, if a, b, and c are integers, then the resulting polynomial has to have integer coefficients in front. But that's not what the theorem's saying. That's just a small little thing, right? This theorem is much more powerful, and yet in some ways it's very weak. Okay, go ahead. Try to do it. Okay, you've come back now. Or you never left. I don't know. So the factors of 8 are 1, 2, 4, and 8, and all the plus and minuses 1. We only have factors of 1 here. So the possible zeros, here's the set, plus and minus 1, plus and minus 2, plus and minus 4, and you may say, well, we always have a leading coefficient of 1. That's not true. It's only because it's only the early examples. Alright, so what we're going to do is we're just going to pull out a calculator and calculate f of 1 is 1 minus 5 plus 2 plus 8. Oh no, it doesn't work. It's not 0. So we hope really, really hard that it's negative 1 because we really don't want to go into those messy examples. And we find out, yay, it worked. We got 0. Okay, so minus 1 is a root. Okay, and now what we need to do is we need to use our division in order to figure out what the rest of the polynomial looks like. And why do we want to do this? Well, we could go through that whole nasty list and we could figure out what the other roots are, but it's much faster at this point to go ahead and divide this thing out and just actually see what we get. This time I'm not changing the sign and adding, I'm just actually subtracting. It was just easier for me to do this time. You can use whichever technique you want, whatever helps, whatever works for you. Okay. Alright, so the thing we started out with, x cubed minus 5x squared plus 2x plus 8 divided by x plus 1 is x squared minus 6x plus 8. You're welcome to use the quadratic formula for this, but hopefully only if you're really, really tired and can't think straight, because this factors really nicely, and this will give you more rational roots, so we're happy. So the rational roots are the first one, which was -1, and then 2, and then 4. Okay, so that's what we have. I'm going to give you another one to do. There we go. Next example. Try, I will give you an example that does not have a leading coefficient of 1, but this time I'm still going to give you an example that has a leading coefficient of 1. I mean, it's since it's something that most of you have not seen before, I want to make sure this makes sense. Okay, so the question is, I want you to exhaustively try all the possible candidates for rational zeros and tell me what happens. Okay, pause. Okay, you've come back. Okay, so the factors here are 1, 2, and 4. Okay, so that means +1 minus 1, +2 minus 2, +4 minus 4. So what we're going to do, and you can use your calculator, f of 1, f of -1, f of 2, f of -2, and you're telling me, hold on a second, you just told me not to waste my time doing them all. But I happen to know in advance something that you probably don't know unless you actually did the problem. Okay, if I go ahead and add this up, okay, 1 plus 2 plus 6 minus 4 equals 5. Okay, and it turns out that -1 is going to look like this. Just look at that. That's not 0. Okay, let's try 2. 8 plus 8 plus 12 minus 4. That's not going to be 0. Okay, -2. -8, +8. We're starting off pretty well, but then we get -12, -4. Not good. Okay, let's try. 4 cubed. Let's make sure we're doing this right. 4 to the power of 3 is 64. Okay, 64 plus, it's actually going to be 32 plus 24 minus 4, not going to be 0. -64. So because when we switch from, f of 4 to f of -4, we just have to judiciously change a couple signs around, and that is still not going to be 0. Let's just go ahead and try this. Try adding this up, because I would like to have a 0 here. No, it's -60. I'm so sorry. Nothing I can do about that. Alright, so what it tells you is this polynomial has no rational roots. That's it. It actually has one real root, because I plotted it and figured it out for you guys. Okay, it has one real root, and it happens to be near a half. Obviously irrational, because it has to be irrational in order to in order to get away with this kind of nonsense. And the other is a complex conjugate pair. So it only actually crosses the axis. I don't remember if it crosses up there or down there. I forget. but it only crosses once. And okay, so you will be asked to find possible rational roots for any polynomial, but only asked to actually find, find the rational roots if either the leading or the trailing coefficient is 0. I'm not going to make you go through a whole pile, a big mess of you'll see. Like the next problem. The next problem is an example of, let me show you what I could ask you. I could say, simply list, but do not tinker with. Simply list all possible rational roots for the function minus 10x cubed plus 15x squared plus 16x minus 12. Okay? And you can give it a letter F. Okay, and the way it works is the numerator must contain, and honestly I don't expect you to list them all, the numerator must contain a factor of this guy, which is 1, 2, 3, 4, 6, or 12, right? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, or plus or minus 12, and the denominator must contain either plus or minus 1, okay, I should list this 1, 2, 5, 10. Can contain plus or minus 1, plus or minus 2, plus or minus 5, or plus or minus 10. So for example, and there are some overlaps, okay? So for example, it could be 3 over 5 works. 6 over 2 is 3, but it's already represented in 3 over 1. So some of these are kind of duplicates. Like 3 over 2 works. Minus 3 over 2 works. I mean, these are all, I don't mean works, I mean these are in your possibilities list. All these things are possibilities. 12 over 1. So anything that says numerator must contain, you can always pop it over 1. So that list is all good by itself. Then you have to, excuse me, go through and divide by 2 and see which things are new. So like 1/2, 3/2 is new, but 2/2 is old, 4/2 is old, and 6/2 is old. Then you have to go through and divide everything by 5 and see what's new. So 1/5, 2/5, 3/5, 4/5, 6/5, and 12/5. Those are all new. And then you got to go through and divide everything by 10. 1/10, 2/10 is already there because we already did 1/5. 3/10 we didn't do. 4/10 we did when we did 2/5, and then 6/10 we did when we did 3/5. So those are all the possibilities, and obviously you have to do the pluses and the minuses. The textbook suggests checking a sketch, but this takes time. So this is kind of advice for people who are using a graphing calculator, or they have let's see, like, here's what I think. I think you should throw away your graphing calculator and just use Wolfram Alpha, and then in that case it's going to tell you the roots anyway. So this is kind of fighting with which technology you're recommending for the student, and I think either go the whole way and use the real useful software, or don't bother with these 1990s toys that are not worth what you paid for them. Okay? And I have one more example in this section. Sorry, this is going to be a long video, huh? But it's really important, and you might even have to watch it again. Okay. Find all real solutions. Okay, so f is x cubed plus 4x squared minus 15x minus 18 equals 0. And so I want you to pause and try it and then come back. Okay, so we have the possibilities. Again, we don't have any leading coefficient. It's just 1, and that's very nice. So the possible things that we can have is plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, and plus and minus 18. And we really, really hope that we're going to get a hit early on so we can just do polynomial division and go home, right? So to speak. Oh, I am home. Okay, this is not equal to 0, so we're going to try again. I'm going to cross our fingers really, really hard here. And this one equals to 0. So this is the time we're going to go ahead and see if this works. Minus 1 plus 4 plus 15 minus 18 equals, yay, it worked. Okay, now we go ahead. I'm not going to do out the long, I guess I am going to do it, but I'll do it quickly. So the long division, you're going to do x cubed plus 4x squared minus 15x minus 18. Alright, and then I'm going to just say x plus 1 goes in x squared, multiply, work this out, subtract, 3x times x is x squared, so then we're going to get 3x, subtract, gives you negative 18x, so we're going to have negative 18. Good. Phew. Because now what we have is something that should factor for us, and if it does, then we're scot-free. 3 times 6 is 18, but we can also coax a 3 out of that additively, so that's great news. A plus on the 6, a minus on the 3. So all real solutions look like this. We just found one here. So x is equal to negative 1, or x equals 3 from down here, or, it's hard to write on this thing sometimes, or x equals negative 6. Okay? And another way of writing, of expressing this is to say this equals x minus 3, x plus 6, and x plus 1. That's what that means. Now I have to figure out how to shut this off.